So good morning or good evening, depending on who you are. Thank you for joining us for our presentation on Java code coverage within Sonar for WebSphere Message Broker. So I've just got up a quick agenda. So presentation will go for about 10-15 minutes, and then we'll just have a few minutes at the end for any questions that anyone would have, or if there's anything that anyone would like me to go back over. Okay, so just a little bit of background. What are we trying to achieve, or why do we care about code coverage? So a few years ago, when people started doing test-driven development, they were finding that doing test-driven development helped improve the quality of the code they were delivering, helped match the code with the business requirements and the user's needs a lot better, because the users were involved in the tests and developing the tests and how code should respond. So as part of the test-driven development or behavior-driven development process, the concept of code coverage came about, where developers and teams were interested in how much of their code was being executed as part of a test, and how much of their code was being tested. It also gave an indication of how much of their code was actually required to complete the tests, which hence completed the business requirements. So code coverage tools in other languages have been available for a while. So in the Java space, you have things like Corbatura, Emma, a few other tools, even commercial ones from, say, Atlassian. And similar also in the say in the Delphi space, or in the .NET space, there are the equivalent tools that allow you to record the code coverage, or the execution, or the code that's being executed as part of a test case, so you can determine which parts of the system have been adequately tested, and which parts of the system might need new testing or additional test coverage. So that's what we're trying to do to achieve with test coverage. As far as code coverage in Java goes, code coverage in Sonar, a few years ago, when Sonar came out, it supported the majority of the major languages, and what they had developed, or what was incorporated in Sonar, was the ability to pick up existing coverage reports that have been generated by other third-party products, such as Corbatura, and use Sonar to match those against the code, and then report the output in a standard way, which we'll just quickly show. Which shows up in the dashboard as this coverage report. Will gives you a amount of a report on covered and uncovered lines. So the ability to do code coverage in Java has been around for a while. I don't know how many years, but quite a few years, as part of the various product offerings that Java has. So what we have here, or what we're talking about here, is an extension to that coverage that allows us to do the similar sort of reporting when our Java code's actually executing inside our broker environment. So on the broad scheme of things, or in a sort of the best practice approach, you would have as much of your test code tested outside of your broker environment by your existing unit tests and by your existing Java frameworks, so that you want to get as much, you want to have as much comfort, or as much understanding of how much code's being tested before it actually goes into the execution group, or before it goes into the broker. And what we're really talking about here is more the edge cases that can't be tested, or can't be tested easily outside of broker through your traditional or your standard JUnit testing environment, or whichever unit testing framework you use. So what we're really looking at here is enhancing your unit test coverage that you would already be getting by having good separation of concerns, good business delegates, good single responsibility principles, by having having classes that do the minimum required and don't depend on the broker itself. So we're talking about the edge cases where the broker is actually involved as part of the execution. So for a while we've had in Be Precise, we've had the ability to do code coverage for, so for example, or maybe not, we'll see if the XSL comes up. We've had the ability to do code coverage for, say, XSL. We've had the ability to do code coverage for message flows to indicate which message flows that a message flow has been tested. As far as the message flows go, we've also had the ability to indicate on our diagrammatic representation of our flows and logic, where the red boxes indicate code that's being tested, while the green blocks indicate code that hasn't. So that's for message flows. And then for ESQ, I've also had the ability to indicate which paths have been tested. So we can see here there's no testing on this particular ESQ file. Or this one. Let's just find, or okay. We'll try and find one that does have coverage to show how it works. Coverage report. Okay, so here we are. We can see indicated an ESQL file where we've got partial test coverage. So we've got the entry into the main is being tested. We've got an if condition with only one condition tested. We have an if else condition with only one path through the only the else condition tested. We have a while loop where we've got the while loop being executed, but only 2 of the 3 conditions being tested. And then we've got another while loop where we've got 1 of the 2 tested. So we can see here we've got different paths through the code, and for our ESQL and for our message flows, we'll see looking at how much is being tested there. So that's what we have existing functionality. So the new functionality that this presentation is looking at is the coverage that we have within Java, within Message Broker. So we can see here. Now we go back to our code. We can see within our Java reporting, we can see here that this particular class has not been tested. While we can see here in our coverage reporting, this particular class has been tested. So we can see here in our SQL, we can see that the evaluate message flow, or the evaluate method has been executed. We can see here we've got a while loop which has been executed. We can see this particular entry into the while loop. We can see the else condition has been executed, and we can see that one of the exception handlers that we've detected hasn't been executed. And then with our second piece of Java code, we can see there's numerous parts, same or similar paths through the code that haven't been tested as part of our test cases. So that's what the additional functionality we're looking at, or additional functionality we're talking about for Java. So in the and we'll just if there's no questions, we'll just pause for a second to see if anyone has any questions. And if not, we'll just push on to a little bit more around the actual instrumentation process and the setup and how we've got to this point. So just to demonstrate what we're doing here, I have a fairly simple ant task. Essentially what this ant task is doing is packaging up a bar file, which is your normal process. And then what it does is takes that packaged bar file and instruments that packaged bar file so that it actually can record the test coverage. It then takes that instrumented bar file with our logic and our test coverage and deploys it to a broker. After it's successfully deployed to a broker, what it's doing is it's starting what we call a test case listener, and then it's running the tests in parallel. And I'll show you that in the end script, but we'll just show it running first, and then it's producing a coverage report, which I'll show you what it looks like. So what we're doing here, we've created our bar file, we've instrumented our bar file, and we're just deploying our bar file. We finished deploying our bar file. We're running our tests, and I said test in parallel. We can see here some results going back to a test handler. I can see here we're just running some tests. And just while that finishes running, we'll just show you what the instrumentation looks like. So what we've got here is this is the file that's generated. This is called the generic code coverage file, using part of something called the generic code coverage plugin that comes with Sonar. And essentially what it is, if you provide the location of the file, which matches to your code in your repository, or your code that Sonar can recognize, and paths, and particular paths in the execution paths within the file, it will help you mark which ones are actually been executed, which ones haven't. So in this case here, we've got a few files. So we can see here we've got a number of flows that have been tested, and then we see some ESQL code that has some covered and uncovered parts or branches. Each of these lines here represents a conditional statement or conditional point, in which case in which we'll see our testing done. And what we can see here for our Java, what we can see here is for our Java, we've got some Java code. We've got no coverage recorded for one particular file, and other Java code we've got, for example, there's another Java code with no coverage, and the Java code I just showed you, which has partial coverage. So what we do is once we've run our report, we've run our tests, or run our deployment, run our tests, we run our report, and what that report does is merges the code coverage report with our source code, and then allows Sonar to analyze the two together, which gives us back our violations and metrics, but then also gives us back our code coverage. And then we've run it in Sonar, we'll see that our plugin's been our analysis is a few minutes ago, and again we see our coverage percentage. Inside the Sonar configuration, there's a one-line configuration file, a one-line that points to the generated file. So one line in our configuration file that tells us tells Sonar what we need to do. Essentially, we just set the generic code coverage report paths to where the code coverage is available from, which is what we've created. And as part of our process, what we do here is we provide some tasks that allow us to do this. The instrument task, we provide additional some test drivers, or you could use whatever you'd like SOAP UI potentially. We have something called a listener, which updates our updates our coverage file when test paths have been executed, and something called the stopper, which indicates to our listener and to our test that we're finished. So what we do as part of our deployment is after we've done our build, and done our create, we do the instrument process. And the instrument here, which is a fairly simple example, where what we're doing is we're telling the instrument process where it needs to be working to. So what it does, it uses that for unpacking and repacking the bar file from. This is the directory of our source code, which tells us where in Sonar, or where our source code is in our directory that allows Sonar to be lined up with. So we need to match our coverage report with our Sonar, with our source files, so Sonar can recognize and merge the two. Keep coverage is where we're telling the instrument process whether or not to create a blank, create the coverage report or the empty coverage report from scratch, or to incrementally add to it. So if you had 2 bar files that you needed to build as part of your deployment and your testing process, you'd have one with keep coverage, or the first one with keep coverage is no, and the second with keep coverage yes, so they don't override each other. Bar file is the bar file that we're looking to instrument. Cover XSL is just whether or not we want to do XSL coverage. Cover Java is whether we want to do Java coverage. And then this is our Java, the Java setting of where we find our WebSphere particular classes that we need to recompile, or we need to use when we recompile our Java classes with the instrumented or the instrumentation points. The coverage path is just where the coverage file will be set to. Now, there's a couple of settings here we haven't looked at. There's the host and the port. So essentially, the instrumentation process works by sending something back to the host with on a particular port that coverage has occurred, or a test path has occurred, and we'll see that we'll use that a bit later on when we do our listener. So the job of our listener is to take the port and the directory of the coverage file is and listen on this port for events that it should record in the coverage file. We've got another ant task here. We've got an ant call to another target, which is to be run in parallel, and we need to do this because we need to have our listener started in a non-blocking fashion, so that it can be running in the background to record all the results from these tests. And our tests look fairly simple. They're just a couple of ant tasks or ant targets with some ant tasks. So in this case here, we've got a URL test. We're basically going to hit a URL, which is going to trigger our logic, and then we've got another URL test, and then we've also got a sending a message to a queue. So we just give it a queue manager name and a queue name, and optionally give it a file name where it can find the data, otherwise it just sends a blank message. And this is a fairly simple test example, just to show that you can trigger the testing in a I guess a production ready environment, or a more fully fledged environment. You would actually have checking of results. So you would have a test that triggers something, but not only would you be interested in the fact that the coverage has been that there's enough or sufficient coverage, but also interested in the fact that the test passes, which is something we haven't indicated here, but something you would probably build into, or you'd look to build into your own environment. So that's the coverage process, and that's how we get it. So just last in a couple of minutes, unless anyone has any questions, just a quick talk about what we can do with this coverage. So this number here itself is good or bad depending on your perspective. So in itself, it doesn't give you it potentially doesn't mean much. It depends on the context in which it's read in. So if you have no coverage and then you start building up your coverage and you get to a coverage of 14%, you could be quite happy you're making progress. If you have a standard coverage that you want to make of say 50% and you're only at 14%, then there's definitely some new classes or some code that hasn't been covered and you want to improve that. What you can do with this is we're going to look at something called the quality gate. Inside the quality gate, you can set some configuration. So if we look at the test gate here, we can see what you can do is you can create what's called a quality gate. And what we can do is set various thresholds for metrics that are acceptable. So in this case here, we've set 2, we've set critical issues and coverage, and we'll just talk about coverage first. So what we're saying here is that we ideally, as far as our development process, we want to see a minimum coverage value of 40%, and if the coverage actually falls below 30%, we want to mark it as a critical issue. And so what we'll see here is after we've run this, and because we've got this, in this case the project's got 14%, what we can see when we go back to our dashboard, when we go back to our project here, we can see that they've got this quality gate marker here. and it's flagged as red, what that's telling us is that our project has failed one of our quality gates. And we can see here the reasons for our quality gate is because we've got a percentage of coverage less than our minimum threshold we set, which is 30%. Because our coverage has fallen below 30%, we've flagged the quality. It's failed. So if you include, depending on which version of Sonar you're in, depending on whether you use the standard Sonar build broker plugin, or if you're on later versions, you might use the open source build breaker. And what that means is you can, as part of a process, stop the process once one of these thresholds has not been met, or one of the thresholds has been met, depending on which way you're looking at it, as either a minimum or a maximum number of things. So the maximum might be for issues, and a minimum might be, for example, duplication or text coverage. Sorry, maximum might be issues or duplication, and the minimum might be test coverage. So it looks like we finished a little bit early. So I'll just let anyone else ask any questions. There's no questions. There are no questions. We'll finish a little early and let everyone get back on with their day. But if you do think of one afterwards, or would like to get in touch, please feel free to reach out to us at richard@bettercodingtools.com. Otherwise, the other option is you can chat to us on our website. Or contact us via our contact page, chat or contact page. Thank you for joining us, and I hope that you got some value out of our presentation, whether or not you are looking at a product like ours, or at least gives you some, hopefully gives you some food for thought about how you do development, and how you handle things like test coverage and test-driven development. Thank you. Please enjoy your day.